Alright, there are two special right triangles that you need to have memorized for any college entrance exams. One is the 45-45-90, which is here on the left, and the other is the 30-60-90 here on the right. The 45-45-90 is an isosceles triangle, so if the side lengths are x, and that means this one's x root 2, and I'll show you how to get that. This one, the relationship is if you have your short leg, so this is the short leg and it's b, then you can double it for the hypotenuse and take it times the square root of 3 for the long leg. And I guess I remember that by it's as simple as 1, 2, 3. You just have to understand that it's the square root of 3. And the reason they're so special, I guess, is you look at 45-degree angles, they're everywhere, 30-60-degree angles everywhere, but 45-degree angles, you know, the sine of 45 occurred so many times while they're designing the Boeing 707 that they just named the plane after it. I don't know if that's 100% true, but I had heard that that is true. So if you type in sine of 45, I have it in there, hit enter, and that's a .707, so they just named the Boeing 747 out of it. I'm going to switch that back, and the reason I switch that back is to remind you to do something here in a minute. And where do these come from? So these come from a square, like the 45-45-90 comes out of a square. So if you knew the sides of a square, if this was 5, then you know this is 5, and every angle is 90 degrees, and if you put in the diagonal, now you have a 45-45-90 triangle, and I can't draw it. So this is 45 degrees, and you could use the Pythagorean theorem to show that this is indeed 5 root 2. Well, 5 squared plus 5 squared equals c squared. Well, that's 25 plus 25 equals c squared. So c squared equals 50. You root both sides, break it down. 50 is 5 and 10, and 5 and 2, and there's your pair. And so c is 5 root 2. So that's kind of fast, but that shows you that it comes from a square and that it's always 45-45-90. And it doesn't matter how you, what the length is. So let's say it's, 8, and this is 8, because this is square, and this is still a 45-45-90. There's your 90-degree angle. So Pythagorean theorem again would call that 8 root 2. Okay, so those are pretty easy ones. What happens if you have a 45-45-90? I'll try and draw it. And let's say this is, let's say it's 6 root 2 for the hypotenuse. Well then, going the other direction, we'd know we'd divide by root of 2. So that would have to be 6, and that would have to be 6, in order to make the hypotenuse 6 root 2. You could prove that. Let's say we didn't know that. It is 6. If this was, whoops, there we go. Let's say this was x and this was x. We could do a quick Pythagorean theorem with that. X squared plus x squared equals 6 root 2 squared. Well, x squared plus x squared is 2x squared. 6 root 2 squared is 36 times root 4. 36 times 2 is 72. And then you divide by 2, and x squared equals 36, which tells me that x is 6 once you take the square root of both sides. So that's the 45-45-90, and the proof for, kind of the proof for that. It all boils down to squares and the fact that you can use the Pythagorean theorem on it. The other one is the 30-60-90. So a 30-60-90 comes from an equilateral triangle. So I'll try and draw one here. That's a pretty good one. And all of the angles, whoops, all of the angles, that one that I put a triangle there, are 60 degrees on an equilateral triangle because all of the sides are the same. Excuse me. And so what's nice about an equilateral triangle is we could split that thing in half. And when you do that, when you draw in the altitude, that's called an altitude, the angle becomes 30 on each side. And then the side on the bottom is half of x. Okay, so this is here on the hypotenuse of that right triangle, that's exactly double x. And then you could use Pythagorean theorem to prove this side here. So let's do this with just a regular length first, so you can kind of get the hang of this. So there's my equilateral triangle. Let's say each side is 12. Whoops. You'd think I'd figure that out. So let's say each side is 12. That kind of looks like a 12. So let's say each side is 12. So when you do that, and we split this thing in half, that means this angle now is 30 degrees. This angle is 90. This angle is 60. And because I split the triangle in half, the short leg, which is this one right here, is half of the hypotenuse, which is 6. Because the whole thing, because it's an equilateral triangle, is 12. So we could find that height, or that longer leg, with Pythagorean theorem. So we know 6 squared plus x squared equals 12 squared. And then by solving that, 36 plus x squared equals 144. You subtract the 36, and x squared equals 14. We got to borrow, I guess. 14 minus 6 is 8. 13 minus 3 is 10, so 108. And probably not what you're used to seeing. And then you root both sides. My math, I do things just a little differently sometimes. And 108 breaks into 2 and 104. Let me pull this down so we got a little more room. Or 54. And then 2 and 27, and then 9 and 3, and 9 breaks into 3 and 3, and I gotta give myself just a little more room. And so we have a pair of 3's and a pair of 2's with a 3 left over. Well, 3 times 2 is 6 with the square root of 3. And again, if you're not familiar with breaking down radicals, that's how I do it, I guess. And so that is 6 root 3. So a lot of this can be figured out with Pythagorean theorem. So let's say we had a 30, 60, 90. We know this is 90. We know this is 60. We know this is 30. And we know this is 5. So knowing that this is double an equilateral triangle, didn't do so hot there, but that's not so bad. That means this side is 10, which means this side is 10. And then you could do Pythagorean theorem for the height here, which we know is 5 root 3. Or I know that because I have it memorized. So that's that part of it. It only gets a little more complicated when you come up with something else. So let's say we've got 30 here, 60 here, and let's say we know this side, the hypotenuse is, I don't know, let's say it's 18. That means this short side, well, and actually, just pause the video, see what you think it is. Well, this short side is the other half of there's the other half of the 30, 60, 90. So this short side is 9 because it's exactly half of 18. And then using Pythagorean theorem, we could find this side, which is 9 root 3. So there's all three sides of a 30, 60, 90. Now, you might be asking yourself, why not SOHCAHTOA? Why not use that? And you can. You can use SOHCAHTOA, come up with the same values. But it's this is just a quick shortcut because 30, 60, 90s and 45, 45, 90s occur so often. The last situation is if you're given the long side. So if this was 30, this was 60, this was 90, and this was 8. All right, that makes it pretty complicated. So to go from the long leg to the short leg, you have to divide it by the square root of 3. So it's 8 divided by the square root of 3. And then to go to the hypotenuse, you double the short side, because again, here's my completed 30, 60, 90. And so that would be 16 divided by the square root of 3. And we don't always like that roots on the bottom. Someday that'll probably disappear. But for now, you need to be familiar with how to rationalize your denominator. And so that would be 16 square root of 3 over 3. And I'm not really showing my work here. And that would be 8 root 3 over 3. This is the square root of 9, which becomes the 3 there. Look up rationalizing denominators of square roots if you're not familiar with how to do that process. Again, something needed for college entrance exams. So let me give you a couple problems to end with. So let's say we had a 45, 45, 90. And then a 30, 60, 90. So there's 90, that's 60, there's 30. And let's say I give you, try to give you something that we haven't done yet. There's 12 for that length for the hypotenuse. On the 30, 60, 90, I'll make it kind of easy on you. Let's say we've got 20 here for the hypotenuse. So go ahead and pause the video, see if you can do these two problems. If you got them whipped, you should have this stuff kind of figured out. If not, find another video. The more you do this stuff, the more you practice, the better you'll be. So step 1 here, we have the hypotenuse. We're going to the leg. So that is, you would divide by the square root of 3. So that's 12 divided by the square root of 3. That's the length of it. Now, if we don't want to have a radical in the denominator, so I'm going to simplify that. So that's 12 root 2 over the square root of 4, which is 2, which becomes 6 root 2. And this is an isosceles triangle, so that means this one is also 6 root 2 as a simplified radical or irrational number. Here you're given the hypotenuse, so you would divide by 2 to get the short leg, which is 10. Take that times the root of 3 for the long leg, and so that's 10 root 3. So those are some 30, 60, 90s. Hope this helps. I'll probably put more up on this because it seems like you need a lot of practice to get this kind of hammered out in your brain. But if worse comes to worse, use Pythagorean theorem. Typically that will help you out. If you're a master of Pythagorean theorem, these problems should be no issue for you at all. See you next time.